Okay, hello everyone. Gonna get started. My name is Rhys and I am joined today by Creasy. We are both engineers at Comcast, and I would like to welcome you all to our talk on architectural design for design systems. So, we will first start off with defining a design system and explaining its benefits. Then, we'll move into the heart of our talk and discuss proper architecture to use when creating one. After that, we will dive into the importance of API design with some examples. Lastly, we will go over some lessons we have learned throughout our experience building and maintaining a design system. So, what do we mean when we say a design system? A design system is a library that contains tokens and components that are shared across different features of an app. When I say tokens, I'm referring to a set of values like colors, icons, spacing, or typography. These values are the foundation for all styling throughout an app, establishing a common look and feel that connects every screen together. Tokens should be named semantically for easier readability, understanding, and recognition. For example, instead of using a color's hex value, a semantic token can simply be named fill theme 1. Components, on the other hand, are likely something you're already familiar with. Common examples include buttons, checkboxes, radio buttons, and toggle switches. They show off content and have actions users can interact with. Components within the design system have customized APIs that build on top of their native versions, ones that are provided from the material library. These custom components should also have options for styling using the fundamental tokens we just mentioned. Let's now discuss why we recommend using a design system. What benefits does it have? Is it worth all the time and effort building and maintaining one? At its core, a design system connects designs and features effectively and efficiently. Components used throughout an app should have the same design. An app is well designed if it works intuitively for its users and is visually consistent. Components should not look differently depending on what part of the app the user is in. Another major bonus is speeding up new work. When a new feature is started, components are ready from the start. By spending the time early on to create a design system, components have already been designed, built, and tested. They also have proper security and accessibility standards out of the box. The new feature work can hit the ground running and will take less time to get into production. Design systems are perfect at handling changes that need to be made across many common components. For example, if a background color of a button needs to change, instead of changing it hundreds of times across many files, the change can be made one time in one file. Once changed in the design system, the background color will automatically be updated anywhere a button from a design system is used. Lee and I are constantly leveraging this ability, and it is seen in particular last year when we updated the entire design system to use Material 3. Instead of hundreds of developers throughout every team pausing new feature work to make the update themselves, we made the updates in our design system, doing the work for them. This saved thousands of hours across our organization. There is one note on this benefit. This requires buy-in from each feature team. Custom or one-off components that are not a part of the design system will not receive updates automatically. I'll now pass it over to Lee to get into design system architecture.
Hey everybody, I'm Lee. We're going to talk some more about how we architect our system. And another way to look at architecture for design systems is that it gives a language to designers and engineers that helps them communicate and work together more efficiently. We're going to discuss how the building blocks help us work with our design teams, then to define needs, manage expectations, and plan work. And most importantly, we're going to talk about how we design the APIs themselves to plug right in easily to what our users are, our engineers and our developers, right? So when I say users, I'm actually talking about our internal teams. And when I say end users, I'm talking about our application users, right? So when we get a new component from our design team, we have to ask a lot of questions with them, because again, it's almost like we're translating design into what our engineers expect and understand, and vice versa. So we want to leverage existing components. We ask what already exists. We don't want to reinvent the wheel, right? Nobody does. If material has the component, which, hint, they do, right? We can just configure it as needed. We might wrap it up so that it conforms to our standards or hide certain features that we don't want our engineers to change. But essentially behind the scenes, we're just going to use material because that's what our Android end users, that's what they're used to. And also our users. Our users are very comfortable with the Compose Material API. Sometimes, though, design wants something fancy. They want a custom animation, or they want some wild motions, or like a floating toast thing that stays around forever and has a really complicated layout. So we like to support that as well, but we do try to negotiate with them about anti-patterns in the Android ecosystem. All right, next we like to build upwards. We ask, what patterns do we see? What screens do we keep seeing? Can they be combined in some way? The less our engineers have to configure and build, the more they can work on the stuff they want to work on. So similarly, if designers already have a template, the designs get faster, specifications faster, and are delivered to engineering faster. So it's an efficiency that comes in from both sides. And finally, reduce reuse of cycle. Again, we really want to make use of already existing tools, whether it's in our library or in material. Some of the coolest work we've done has been like the show-off work, like data visualization stuff, and that's a lot of fun, not very reusable, but it's what design wants. But for the most part, when we build a new component, we want to consider where and how it will be reused. Because if we build a component that is meant to be reused a lot, but we only build it in one context, we will expect bugs when an engineer tries to use it outside the context that we originally intended for, if we haven't already thought that through. So here's our blocks. So tokens, color, spacing, typography, they're just constants that define a consistent look for our components. Hopefully you got to catch Arash's talk earlier. It was awesome. Thank you. We thought it was great, but we're not going to dive that deeply into tokens. We have elements. So elements, and then we have components, patterns, and templates. Components are like buttons, cards, checkbox, line item, that kind of stuff. Patterns are like accordion stuff that's a little bit more complicated. We put our app bar into a pattern bucket. And then finally, templates are usually for like full screen takeovers, but I'll get into that next. Our tokens are automated to generate for all platforms. Again, Arash did a great presentation on this. We output to all of our platforms. Another thing that our app, and it also supports dark mode, light mode. The other thing that our app does is we white label the app. So we actually really use tokens and our token automation to support behind the scenes, so we can swap out color sets for the clients who buy our application, right? Because every brand's going to have a different color set. Some of them like to tweak the rounded corners on the buttons, for example. Well, we can do that. We can do it very efficiently, and it's all push button. Just as an aside, we don't output directly from Figma. We keep it in like a basic JSON format, mostly because when we developed the automation, our design teams weren't yet on Figma. So next up is like the bulk of our work, right? Our components and our elements. And the way that we define it is that elements are basic components, most often already provided by material, whereas components are a little bit more complex, either by interaction or by configuration. So some elements like dividers, we've actually opted to do our own divider, but it ends up being like pointless because our engineers are fast enough and good enough that they make their own compliant dividers. The biggest problem here, and what we really want to drive home with our engineers, is use the design infrastructure that we give you so that when there's an update from design, and there are many, you don't have to update it yourself and you're still design compliant because you've got the latest version of our module. Components are where things get more interesting. We consider components to be our more complex interactive APIs. In cases like buttons, we also provide a lot of extra configuration options. Again, just to support over top of material, we support configuration options that are specific to different states that design likes to use to communicate with. Especially for us in the Xfinity app, we have like an online state, right? When your Wi-Fi is actually connected to the internet, versus like an offline state or an error state. And then finally, we have patterns and templates. So simply put, patterns are a way that we organize our components into content slots, and we'll get more into slotting later on when we talk about the actual API design. But like our app bar or alert dialog, those usually fall into our patterns bucket. Where we draw the line is at scaffolding. So we do not include any scaffolding APIs in our design module. And the reason for that is because when we start talking about scaffolding, it's already at the app layer, and we just haven't really found a good architectural way to provide scaffolding without having to have some level of app code and business logic in our component, in our module. The other big differentiation for us with templates is that it's a full screen set of content. In some cases, we like to use templates as like an easy formal touch point between all of our other components and our app's components specification data, which means that the templates live outside of the main library that Rhys and I deliver, and actually lives in the app code. And the other reason for that is because from a technical standpoint, that's not going to get reproduced by another application in our ecosystem, right? That's just all very specific to the app. Now, we do maintain it because it still is very much the responsibility of design to provide these templates to our engineers. And that really helps us to keep all opinions about data completely out of our main library. It also helps us when we start talking about dynamic CMS-driven features, or even like server-driven UI features, where if it's in the app layer, then we have an easier time supporting it. Whereas if it's in our module layer, it's going to cause a little bit more headaches in terms of like reproducing for new features, like reusing it for new features. I'm sorry. The other things that we use in templates is like our navigation. We don't want that in our module, and different logging features that our app has. All right, so I'm going to pass it back to Rhys, and we're going to get started on what our APIs actually look like and why.
Thanks, Lee. So for API design, this is especially important within a design system because of the amount of use each API will see. Your design system will be used by a multitude of other developers. Some you may be close with, while others you've never interacted with before. We want to design APIs so that anyone can use them effectively. For any API we create within the design system, we want to ensure these three things are true about it. First, that it's adaptable. APIs are developer-facing contracts. They should be ergonomic to the native component they are customizing and have the flexibility to change for variations in design. If an API is too rigid, it won't get used. Next, it should be accessible. Custom components need to have proper accessibility out of the box. The only accessibility we want implementing developers to worry about is that of the entire screen where the component is being used. And last, it should be compliant. The power of the design system is that components already meet design specifications and requirements. Like accessibility, this saves time for anyone implementing your design system APIs, since they do not need to be concerned about each individual component. On top of those requirements, we stick to these three guiding principles when designing new APIs. First, we want them to be clear. Components should have a clear purpose and structure. These customized APIs should resemble the native components that they are building on top of. They should also be simple. We simplify method signatures by providing overloads that set default values. By creating increasingly simplified methods, we rely less on a single large method with many parameters that implementers would have to worry about. And instead, the single large method should, however, remain public and usable in case there's a more customized component needed. We see this pattern used a lot in Material, which is why we try to follow it as much as possible. It should also be explicit. When designing APIs, naming should be explicit and obvious. Parameters and helper functions should be named for what they do. Customized API names should include the native component they are customizing. Let's look at a common API example, text input. I've broken the design down into the main structural elements like strings and icons. Each of these elements should have a customizable parameter in the API. But we should also provide some helper functions for elements like the trailing icon. Its primary use cases will either be as an X icon to clear the text field or as an I icon to hide the current text. We can create helper functions that provide the proper icon for the proper use case. In addition, an alternate option we have here is creating a separate text input API that is specific for passwords. In this case, we would omit the trailing icon parameter and set it internally as the I icon as appeared. So here's that same text input, and we'll now make our own API for it. I have shaded any of those main structural elements that I mentioned in the last slide in green. I've also shaded parameters in yellow that are standard for either all components like modifier or text inputs in particular like keyboard actions. What we are left with is all design-focused parameters. Text style will change the style of anything typed within the text input. Validation state will update the component to be in an error state if the input is deemed incorrect. This error logic is usually handled by any engineer implementing the API. But here you will also see a tone parameter. This is for providing base colors like for outline, container, and content. In the native Material 3 components, this is typically provided as a color object that has overridable default colors. I'll now pass it back over to Lee to talk about API designs with composable slots.
Yeah, and I just want to add for that example, we're already in the process now of updating, like if you were at the Google's presentation of the new text field API, we're like already in the process of updating that. And we're really excited for those new features that they showed because it's definitely going to simplify what we do under the hood as well as simplify the API surface for our engineers. Anyways, you all should be really familiar if you're using Compose with slotted APIs. They're really simple APIs that allow for variations based on scoped composable slots. We try to always, for these ones, always include a modifier parameter. It's super important. We find that not only is that like best practices for Compose and Material, but like we find that our engineers already know how to use it pretty well. And yeah, it's a great thing to use. Always have a modifier parameter. They should always include, we try to always include a content padding parameter. What we've found is that when our components get used inside other components, oftentimes there has to be some adjustment of the padding values. And if we don't provide a content padding param, we will immediately hear from the engineers. We like to use, when we use our slots, we like to use only like nullable logic, right? Nullable types, so that we can seamlessly hide or show that content slot without including any extraneous padding on accident. That's a pretty common issue that I find. If we hide the component and don't hide the spacer, we're going to get a bug ticket. So we always try to make sure that we're aware of that and that that's part of the API, so that it's also clear to the engineer. They don't have to worry about that. And then in some cases, we do need parameters for just simple data types. We can provide values using local content providers for styling inside slots, but we really prefer to parameterize all of the values that configure our components. And that's because what we've found is that that makes it so much easier for the engineers to understand what's required and how it's used. Whereas abstractions like DSL, scoped DSLs like row scope or column scope, we've made our own and then immediately regretted it, because constantly supporting engineers to help them find what those functions are easily. Whereas if all the parameters are just up front, then everybody gets the designs and is able to plug it right in immediately. And this is just a little diagram kind of for this segmented bar example, which is a data visualization tool. And when we get a design specification like this, it's easy to identify how we're going to want this broken up, right? We've already got the margins and the padding and everything set up, and those are pretty straightforward. We keep those internally, like I said, except for the content padding where necessary. And we'll usually default it as well. Really, the most magical part of this is just how we're going to configure and render the little graphic at the bottom. Otherwise, we're providing, in this example, 2 content slots for them. That really allows for maximum flexibility, and our engineers are very comfortable with it. However, there is always the question of what goes into those slots. And so here's a full example of a slotted API when we're scoping to column scope in this example, and the labeling for the header and content. It's very straightforward. It looks a lot like most of the other composed material APIs that you see. And this one just is specifically to draw the segmented bar column. The next important kind of API that we have is a styling API. We follow materials pattern really closely here, but we do like to provide those state enumerated classes just for some cases, just because, again, part of our job really is leveling the playing field between design and engineering so that they can communicate better. So if design is specifying different states for a particular component, we like to go ahead and under the hood provide an enumerated object that makes it easier for our engineers to use with the when statements with their logic. But yeah, it's basically a class, and we give it the parameters with a defaults object that can be copied. We do like to include the copy method as well. I find, like, from a engineering standpoint, it's just like really easy to use a good copy function and just include the parameters that you want and ignore the ones that are okay to be defaulted. And then below is the component state. Again, in this example, it's just online. And it gives our engineers all of the colors, all of the configuration that they might need for that particular component. And some of our components have a lot of configuration options, button being like the most obvious one. So again, it's just anything we can do to help speed our time to market for our engineers so that they can focus on the important stuff that they like to work on, and also so that everybody is really friendly with our designers, because sometimes that can be really hard. And so finally we have, so here's our explicit API. Explicit APIs we like to use with basic data types to support CMS applications, or when we're supporting our slotted APIs, we provide what we call like helper APIs, helper methods. And so in this example, the header and the label are going to be existing components in our library that engineers and designers can use as a sort of shortcut and plug them right into the component slots. We prefer not to use scopes. Again, like I was saying, with scopes and DSLs, it's a really cool trick, but we find for providing an API to our engineers, it's a little bit too magical, and we're constantly trying to help them with support, and nobody really likes wasting time doing that. So we try to avoid that as much as possible. But basically, helpers are really simple composables that intend to emit a very specific UI for use within that larger context. In this example, the segment and bar. And then here's everything together. This is our segment and bar with the two slots using the explicit API helpers. And you can see it's like very simple. And I think really honestly, this is one of the things that I love the most about Compose is, I mean, we're not talking about classes hardly as much anymore. And it's just this really elegant method signature that's easy to use and easy to implement for our engineers. And then our job entirely is like once they write that line of code, they have a high level of confidence that this is exactly what their designer for the feature they're working on wanted in the first place. And then the other big hiccup is CMS. So it would really be nice to always use content slots, but CMS data doesn't really translate to Compose directly. So you have to have a way to like convert everything over. And so far right now, with the exception of like in efforts to do server-driven UI, we just like to do really simple data types and kind of ignore slotting where in these cases, right? Because it all comes in as JSON. And so we found that our engineers like for us to just provide them direct parameters that come from JSON as like strings and integers and stuff like that. But also it simplifies the logic for our user, the engineers. And we simplify the process by also providing like a resolver API, which we're not going to get into today. And that helps also with translating whatever data they're getting, because sometimes the CMS has a very interesting data structure that they have to work with to get it into our API. So we try as much as possible to help them out with that. So I'm going to give it back to Rhys, and he's going to talk about some of the lessons we've learned over the 2 or 3 year process that we've been developing specifically in Compose as we've sort of basically abandoned our XML library.
Thanks, Lee. We've tested different API structures and learned some things that should and should not be avoided. So first, like as Lee mentioned, we want to avoid using DSL structures like the one used for lazy lists unless the content is acquired lazily for layout reasons. Also, avoid creating APIs that are classes with a composable content method. Both of these structures create unnecessary complexity for anyone looking to implement the API. We ultimately found the best structure is the basic composable function. It's powerful, yet easy to understand by both us as design system engineers as well as the implementing developers. Remember, we want our APIs to be clear, simple, and obvious. Use functions for the clearest and easiest API designs. Thank you for coming to our talk, and feel free to ask us any questions you have.
Hello. I have a question. So, do you have a catalog for all available elements in the library so that a developer can find an existing component and understand which one is needed in their case?
Yeah, we actually create our own reference app. Oh, sorry. The question was, do we have like a catalog that people can use to see all of the components that we have in our design system? And the answer is, yeah, we have a reference app that is only available for internal use for other developers within the organization. They can use it. They can run it. It's just through our like our repo that has our design system. Um, we don't actually like publish it out, but they can use it to see what components are available, what updates we've made, as well as any design tokens that we have in the design system. Do you want to add anything?
Yeah, and we do have automated documentation that we publish as well. But I forget the name of the tool because it's so automated. We don't even have to deal with it. It's one of those ones that takes markdown. We write the markdown, and we also try to keep like a wiki in our repo of like implementation guides and stuff like that. But the real key too is on the design side, right? Design needs to know the same language, right? And vice versa, because design has some language that we have adopted in engineering. And that's really where the rubber meets the road as well, because if design is using a word or a naming structure that the engineer's not aware of or that we don't have, it can cause a lot of churn.
So I have a question related to the API design. So let's say you need to revamp a component, and the API design changes significantly. Because you also have CMS and then you also have the server driven, how do you keep like all those schemas, API design aligned despite like changing APIs?
Yeah, so the question was, let me make sure I got it right. How do we manage API changes, especially particularly as it relates to server-driven UI and CMS UI? That's really why we keep it separate. That's a great point about why we keep it separate, right? We keep those APIs in the app project, in the app code, in large part because of that. In terms of the other components, when their APIs change, it's a case by case basis. We have several V2 things, and as much as I would like to avoid that, we in the past, one of the lessons learned I forgot to add to that slide though is ABI breaks can be very common and devastating because they don't show up at build time. They only show up at runtime. And we finally got a tool that dumps out our API so that we can get a diff of what's changed in the binaries that we deliver, so that if we see like if there's a line removed, we know that we've broken the binary and we have to go back and either provide a new method, which is another reason why we love Compose, is because it's so flexible in that way, or we have to like backtrack. And unfortunately, we've learned this, so we don't do the backtracking part as much. We have to backtrack, redesign the API, and release it again. That doesn't happen a lot anymore since we got that tool.
Thank you.
Yeah, thank you very much.
Hi, with the token, styles, and component, how do you handle accessibility?
Yeah, we. So the question was, how do we handle accessibility? We're very close with the accessibility team that our org uses, and we are constantly getting they're brought in almost as soon as we are when we're talking about like a new component or a new design that's coming up. We have a weekly meeting that members from all teams join and discuss a new design. And then while we're developing it, we also are constantly checking in with them to see if we're handling accessibility the right way, if we're forgetting anything. And we actually have them review the APIs that we're adding to our design system as we're adding them before they go out to feature teams. Do you want to add anything?
Yeah. And also specifically because Android handles or because Compose handles all of that through the modifier, very many of our components do require the engineer to include accessibility as well. And what we do is we, in the demo app, it is validated for accessibility. We actually have really high accessibility standards because we partner with Sky in Europe, and they're very litigious about accessibility. So if we don't have it right from the get-go, we can get fined, right? So what we found is, one, internally, we're validated 100%. And then when we pass on the components, there's accessibility documentation that's already been validated by us. And he was saying, we partner with the accessibility team. And we have the examples in the demo app that if they're like, this isn't working, we don't understand why, we first point them there to say, hey, did you try the way that we're doing it with the demo app? It's kind of an unfortunate thing that we can't do it, but it's also nice because I do think having it on the modifier makes a lot of sense. It just does add a lot of extra work for our engineers because it ends up kind of being external to our APIs in a lot of cases. Yeah.
Yeah, just a quick question about tokens. Which do you guys use any framework for converting colors to tokens library, or how does it happen? For example, Figma to color tokens.
So just to make sure I got you right, it's how do we convert our tokens into like Kotlin basically?
Yes.
Yeah. Okay, so like I said before, we don't use the export feature for Figma. We had already built our own automation, and it's basically a node application. It takes in JSON, and we have different kind of transformer functions in JavaScript that all runs on GitHub Actions, and then outputs and publishes all of the tokens to Android library, iOS library, web, TV, etc.
Yeah, nice, because at my workplace, we also have kind of a similar implementation for these components, and we use Specify, but the company is going down. So yeah, I haven't worked on that part, but I just wanted to ask if.
I wish I had like something easier. We just were like we really needed it, and we didn't know if there were any solutions like that. So we literally rolled our own on that one. And actually the same thing, we try to automate as many of the inputs that we get from design. So we also have like an icon situation that's similar to our token generator, where our design team is constantly building out new vector icons for the library, and we can't keep up with it. It was wasting a ton of time. Every time they would put in a new icon, we'd have to get it out to all of our platforms. And so we have a very similar thing where it just downloads all the SVGs, and then we have some conversion scripts to massage it for Android, and then like for iOS, it just dumps it. They get lucky. So yeah, we're really big on that in-house stuff right now, at least.
Yeah, just one more question.
Yeah.
About the Node app, how does it communicate? Is it using Figma APIs to get the colors, or I don't know if you know about it or not?
And I forgot to mention this. So how do we get the tokens from design, essentially? Yeah, they do that themselves. I could be wrong, but they just make a commit right to the repo, and then the action kicks off. And they don't have to worry about it. So it does require on their part some technical expertise, since we don't support the Figma type thing. But for us internally, it's kind of been a thing where we haven't yet tried to improve the system because we're not really, ownership of that software is no longer as clear as it used to be, unfortunately.
Yeah, thank you very much. Very nice
thank
talk.
you.
Sorry. No, we're done. I'll ask you after.
All right, see you later. No, come on.
I was just going to ask, when design makes new tokens or makes changes, like we want the purple button to be red, do you guys have the ability to do A/B testing? Like half of users get this color and this, or is design picks and that's what it is?
Not really, no. Yeah, it's pretty set with what we do.
Time to add another layer, right?
Yeah. Thank you.